to have you all here. I was just telling Harold, often with seminars there's the usual suspects, but there are so many faces I don't know. So it's great to see all of you, and thanks so much for coming. Today we have Harold van Es here, professor in soil sciences at Cornell University. I first met Harold when I was working at Cornell doing my postdoc on a bioenergy project in which we were looking at soil health. And his lab and his team, they were analyzing our samples from our site. And then when I came back to Wageningen, I started working at Altera for a little bit, and I was like, all right, in Europe we're talking about soil functions, but here in the US there's this team that has developed this framework about soil health, and soil health was the thing. Now, long story short, we're setting up a collaboration with Harold and Wageningen and Altera, or University and Altera. And Harold is on his way to Bulgaria for another meeting, and he made a stop over here to come give a seminar about their work, about soil health, and also about nitrogen management. If you have any questions, please keep them for after the presentation. There will be time for discussion then. And now I would like to give the floor to Harold.
Dankjewel, Katrijn. Ik begin even in het Nederlands om te bewijzen dat ik nog steeds Nederlands spreek. Hoewel ik na 35 jaar dat is een beetje aan het verslijten. Maar het is heel leuk om hier te zijn. Bedankt voor komen. Ook leuk om het gezichten te zien van vroeger. Dus ik ga door in het Engels natuurlijk, want alles is in het Engels opgezet. So soil health is kind of an exciting opportunity. It's kind of evidence that society is interested in the soil for itself again, and to see the soil as a national treasure and something that's important and a foundation to life. And so in the US it's a fairly big deal these days. So when I talk about soil health, and this presentation will be relatively high level, I'm not going to go into a lot of details, but we kind of, when we present soil health, we say, well, this is important for the food system, agriculture food system, and for the environmental health component. That ultimately humans, experience soil health through those two routes, and that's why it's important. You know this, but it's important to point that out. So in the US, in the past couple of years, it's really been amazing how much has been happening around soil health. So the national government, the US Department of Agriculture, has a major soil health initiative that they started about 4 or 5 years ago. We have a soil health partnership, which involves the National Corn Growers Association and some companies like Monsanto. The Soil Health Institute is brand new. It's funded by the Nobel Foundation and the Farm Foundation, and that's also associated with Soil Renaissance. I just read yesterday that, for example, the Field to Market initiative, which is a supply chain initiative associated with a lot of the food and beverage companies, they're interested in soil health. So for us it's very gratifying, because we've been working on this for 15, 20 years, and we've been saying soil health is really important, and nobody listens, and then somebody in Washington says, hey, we're going to do soil health, and now it's a big deal. And so for us it's nice, because we're front in line for the funding, because we've been doing it for a while. But it's very gratifying. I mean, in general, I hear the same here in Europe, that there's just kind of a realization that soils are important again, So we fairly early on decided to focus on quantification. Basically, the adage of you don't know what you don't measure, or what gets measured gets done. And when you think about successes in soil science, the soil testing, which is really soil nutrient and pH testing, has been tremendously successful. Farmers use it, they know how to interpret the numbers, they know how to act on it. So we decided, well, let's just expand the soil testing concept to go beyond just nutrients and pH and metals and all that. Let's bring in the physical and the biological component of the soils. So you know this, so there's all these important processes in the soil that we can sort of group into physical, biological, and chemical, yet they sort of interact and they come together in the concept of soil health. And so soil health is really about how the soil functions in those three realms. So we've been focusing especially on the chemical part, on the nutrients and pH and all that, but we decided, okay, we need to then expand that to these other components. So we developed this framework and we rolled that out in 2006. So we're now 10 years where we basically offer a soil health test on a for-fee basis. And we decided to focus on soil constraints. So there was a lot of debate about soil health, soil quality. Do you want to have an overall score? And we said, well, it makes more sense to look at where the problems are, because that's the way you do it with traditional soil testing as well. You know, if you're low in phosphorus, then your recommendation is to address the phosphorus problem, right? You don't say apply potassium fertilizer if you're low in phosphorus. So focusing on constraints. So we basically decided, okay, which are really good indicators to measure? You know, physical and biological. We just accepted the standard soil test for the chemical realm. We didn't mess with that. That works. People know how to deal with it. So then you have to sort of select, well, what's a good indicator? What's a meaningful indicator agronomically, because we focused initially on agriculture. Is it easy to measure? Can it be done relatively inexpensive? Are there sampling issues? Can it be consistently measured? Do you have a lot of temporal variability? Blah, 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 those kind of things. So we basically came up with these indicators. So 4 physical ones, maybe it's difficult to read here. Available water capacity, surface hardness and subsurface hardness, and aggregate stability. Then 4 biological ones, and I'll explain them in more detail. Organic matter, a protein index, respiration, and active carbon. And then we have the standard nutrient pH test. And so this is an example of a report that you would be getting. You get a measured value, so aggregate stability of 39%, and then we get an interpretation of that, and I'll discuss how we do that. But we really designed it to be a guide for decision making, especially management decision making. So this is what basically, again, what they are. It's listed a little bit more clearly. So this is the standard one. Now in gray here I have what we call optional add-ons. So that's basically not part of the standard test, but you pay a little extra to get those done. So for example, if you're in an urban environment, you may be concerned about heavy metals. But if you're in an area where you really don't expect any heavy metals, then you don't spend money on it. And same with soluble salts, that certain environments where that's a problem. So those are the indicators. You're familiar with them. They're fairly basic, and I'll explain them in a little bit more detail. Okay, so, but it's important, when we designed the test, we really thought about functions and processes. So we wanted to make sure that basically every important process that we are concerned about with soils is represented in this test. Right, so each of these indicators has a number of these processes associated with it. And, arguably, we kind of captured all the relevant processes in this soil health test. So this is so people send in a sample. We require about a 1.5 liter worth of samples. It's a little bit more than the standard test. And then it comes into our lab and it gets dried and 8 millimeter sieved, and then it goes through some of these analyses, and then it gets ground and 2 millimeter sieve, and then some of these other analyses. I mean, this is fairly familiar stuff probably. So I'll explain each of these in a little bit more detail. Okay, so the standard component that's been around for a long time is basically the nutrients pH, so we're just set up like any lab. You have one here on campus as well. So you just you use your ICP emission spectrometer, and you measure your pH and soluble salts and organic matter. So that's standard stuff. So for the physical indicators, so we have aggregate stability. We use a rainfall simulator approach so that we know exactly how much energy we apply as part of this test. I mean, there's other ways to measure aggregate stability, of course. We do a rapid soil texture. You kind of have to do that to interpret the numbers. And so this is a more rapid method, not quite as precise as the standard maybe pipette or hydrometer method, but it's a lot less expensive. And then available water capacity, most of you will recognize the pressure plate equipment. And this is the only measurement that's made in the field. It's a penetrometer measurement. And it's always controversial because there's somewhat dependent on moisture content. But basically, if you do the sampling at more or less standard times, at the shoulders of the growing season, you really typically end up with very good numbers. And the other thing is, and I'll come back to that, what we find out is that the subsoil has really been ignored. We've put so much effort always in measuring things in the surface layer, and the subsoil is really something we need to pay more attention to. So in terms of the biological indicators, so we really, we always think of organic matter being critical, but there's really organic matter quantity and quality. So for example, we measure protein. Protein is an important component of organic matter as it relates to nitrogen availability. And you could have really, for the same organic matter content, say 4 or 5%, you can have a factor 3 difference in the protein content. So there's not just organic matter, there's a quality aspect of organic matter. Okay, so what are some of those indicators? So active carbon, which is the permanganate oxidizable carbon, very simple, very inexpensive test. Maybe some of you have used it. You just need a basic, field spectrometer, and then it's a basic, chemically speaking, very basic test. It's really quite good. I mean, if you do a lot of analysis on overall soil health or soil quality or even crop productivity, one of the indicators that tends to come on top is active carbon, and it's a really inexpensive test. Okay, so it really focuses on sort of the component of the carbon that's more biologically active. We also do respiration. That's a microbial activity measurement. Okay, that's we do a basic rapid welding with a KOH trap, and we just use an EC meter. Very inexpensive, very easy to implement. I mean, this kind of equipment, you're talking about less than $1,000 to be able to implement something like that. And so it's a microbial activity indicator. You also do the autoclave citrate extractable soil protein. It's a little bit more involved test, but we feel that proteins, because of the nitrogen component being so important in the soil, is an important test. But it's also relatively, the equipment needs are relatively modest, actually. And then as an option, or we call it an a la carte option, we also do a root disease assessment, which is an integrated assessment. So we just basically do a bioassay. We grow these bean plants, and then we do a rating of the relative disease level, looking at lesions and looking at necrosis of roots. This is developed by a plant pathologist. Probably in the future we can be more specific about particular diseases, but for right now this is a very inexpensive way. And it's especially the organic producers that are very interested in this, vegetable producers that grow crops that are more susceptible to diseases. So okay, so then so those are basically the indicators and how we measure them. And here is again is our report, right? So I'm going to talk a little bit about how we basically come from or go from the measured values, so aggregate stability, say 39%, or active carbon, 619%. So what does that mean? What do those numbers actually mean, right? So that's been one of the challenges. So we basically convert that into a score or a rating, and then we use color coding, basically, red being bad and green being good, and then some in between colors. Okay, so that works well. And then we have an overall quality score as well. Okay. So that allows you for kind of an overall assessment, maybe what's the value of that soil. Okay, so in terms of scoring functions, we have 3 types: more is better, less is better, and optimum. So more is better, like active carbon or respiration, some of those. Less is better is, for example, penetration resistance. The harder the soil, worse it is. And optimum, of course, is mostly pH and phosphorus, because phosphorus you don't want to have too much and you don't want too little. So this is following some of the work that Susan Andrews and that group did at the ARS. And then we, by the way, we used on the color coding here. You can see it's the 5-category system. We now are all living by the 5-star system, right? Everything is 5-star ratings or 3-star and all that. So the human mind thinks in terms of 5 categories. So we actually started with 3 categories, and then we found out that people started to parse things out. You know, if you say high, medium, low, people will say medium high or medium low. People always want things to be in 5 categories. So we said, okay, we give up, we're going to go with 5 categories. So okay, so scoring methods, so how do you approach that? Well, one is to say, you know, we already know what's good, like pH. We already know that if you're growing maize or coffee or whatever, we know kind of what the optimum pH is. We don't really need to do any more research on that. Same with phosphorus, potassium, etc. But how about active carbon, right? Or protein? I have no idea. So basically what you do there is you compare the measurement in a larger distribution. And that's kind of what we use in human medicine as well. So if you have your potassium level measured in your blood or your cholesterol level, you know, the number itself doesn't necessarily mean anything, but they just compare you to a population. Okay, so if you're at 200 and most other people average 120 and range from like 80 to 220, you're at the high end. Okay, and that tells you something. Doesn't necessarily say that there's a problem, but it tells you something where you are. And that's the best you can do with these new indicators. And that's actually a fairly simple way to approach that, basically by using the normal distribution function, and then you develop a scoring function from that. So here's an example. So you collect a lot of samples, you measure, in this case, active carbon, you get your distribution function, you define your parameters as part of that, and then you just plug it into this new distribution function, which is the cumulative normal distribution function, which uses the same parameter of mean and standard deviation. Right? So all you need to do is you need to basically characterize the distribution of your numbers. And so that cumulative distribution function looks like this, and then you basically have the different categories. So 0 to 20 is red, and very low, etc. It's actually very simple to do from a mathematical perspective. So we've done that. We started out 10 years ago, and we developed these scoring functions. This is for aggregate stability. And then after 8,000 samples, 9 years later, we said, okay, let's kind of revisit those scoring functions. And we found that we kind of had to adjust them a little bit, basically a little bit to the left. That we kind of overestimated aggregate stability because our initial sample was somewhat biased, basically. We maybe had too many organic farms on there or dairy farms that had a lot of manure. And then we also, like I said, changed from the three color system to the 5 color system. Because, you get people, say, oh, I'm still in the red, but, my aggregate stability is actually quite good. And that's really kind of discouraging to people. It's like, oh, geez. Or they measure 1 year, and then 3 years later they measure, and I'm still in the red, or I'm still in the yellow. So you need to allow for a little bit more graduation. Okay, so how do you then take this information and make it useful? So one of the mistakes that we made was because we focused on measurement. We said, oh, here's your soil health report. Isn't that great? And people were like, what do I do with this information? Okay, so we really had to help people interpret these numbers and start to use them effectively for management planning. And one of the challenges with that is that it's not as straightforward as traditional soil testing. If your phosphorus level is low, you can say apply 40 kilograms per hectare of phosphorus or whatever, 60 kilograms per hectare of potassium. It's very easy. Soil health is more holistic management, kind of like with humans. You measure your health. And so it's a little bit more complicated. It's not always that straightforward. You have different options. Okay? And I'll try to explain that. So one of the things that we realize is we need to have a process. I mean, it sounds very simple, right? But that's what you need. You need to help guide people through this information. You say, okay, well, we develop a 6-step process. So one is to put it in the context of the enterprise, the farm. What kind of equipment is available on the farm? What's the financial situation of the farm? Are they able to invest in new equipment or not? Things like that. What's the attitude of the farmer? Is it a young 32-year-old farmer who is a go-getter, or is it somebody who is in his mid-late 60s and maybe he's willing to change one thing? Okay, you set some goals and you sample your soil, then you basically do the analysis, you send it to a lab, and then you identify what the problems are, and then you based on that, you can prioritize. Where are the reds? You know, if you have a lot of red in certain areas, then that's where you want to focus on. Then you look at feasible management options, and I'll explain that a little bit later. So you say, what are ways to solve this problem, okay, and address this constraint, and then you create a management plan, right? It's a more long-term management plan, and then you do this sort of implement, monitor, adapt, so that you can kind of make it into a circle, right? And so again, it's very logical, but it's what you have to be explicit about this, because otherwise people are very confused. They don't know what to do with the information. So the report actually is, in addition to having, actually this is a previous version of the report, my apologies, but the report is quite extensive. It's an 8-page report. So we explain exactly, for example, aggregate stability is a measure of how well blah, 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 blah. So you really explain to people very well what you're measuring and why it's important. And then it says your measured aggregate stability value is 22.5% with a score of 26, and so therefore you may want to address this because it's a low score. So the report, everything is electronic now, so you might as well put the information in, because it's useful. So as part of the report also, we try to link the constraints to the management practices. So if you have, say, low aggregate stability, then these are some of the suggested either short-term or long-term management practices. So in this case, incorporate fresh organic materials, use shallow rotation or cover crops, add manure or green manure or mulch, and in the long term, maybe you want to reduce tillage, use surface mulch, maybe rotate with perennial crops or something like that. So we're giving certain recommendations because we understand how, say, aggregate stability may be influenced by these management practices. But what you'll notice is that some of these management practices will show up with multiple constraints, multiple indicators. Okay, so so when you start looking at that and you see, okay, I have mostly red in these areas, and I see that some management practices basically solve multiple problems. So that, of course, then becomes a very attractive approach. All right, and of course we know, so here's some consideration, we know what works, right? We know what's not so good for the soil, we know what's good for the soil. So we focus on, so if for example, there's a lot of intensive tillage going on, maybe you can reduce the tillage, right? That's an obvious thing. And so it's this process of trying to kind of sort through all the options that you have so that you can actually give a good management recommendation. So acknowledge that it's a more complicated crop and soil management structure. All right? And again, we often use that analogy with human health. So you get your blood test done, your cholesterol level comes out high. What are your options? Well, look and see what maybe the problem is. If you always eat very unhealthy food, then maybe that's what you need to focus on. Maybe you never exercise. Maybe that's what you need to focus on. Maybe you have a lot of stress in your life. Maybe you need to try to reduce stress. Or maybe you just need to take a pill. Okay? You have those options. You have to sort out what that is. Maybe you sit down with your physician or something like that. That's kind of the way this is. All right? And this takes a little getting used to it because people like to have very straight and simple answers. All right? But that's not holistic management. So keep in mind that, for example, a cover crop can address a lot of these problems, okay, depending on what kind of cover crop you select, say a legume or a grass or whatever. Of course, one particular problem can be addressed by multiple management practices. All right, so you kind of have to sort your way through that. And typically, something very obvious, rolls out. For example, if you're on a grain farm and you're near a dairy farm where they have excess manure, well, maybe you can get some of that manure, and that will help you improve your soil. Or maybe you can change your rotation, or go to strip till or no till or something like that. Okay, just to give you a little sense of what we offer at this point in time, we have a basic. Well, let me start here with the middle one. So this is our standard soil health analysis package, and we currently charge $95 for that, and that includes basically what you've seen before. Okay. Then we have kind of an entry-level package that's a little bit more. If you maybe if this is your second analysis, or maybe it's a homeowner with a lawn or something like that, they don't want to spend as much. So we kind of have the $50 option, and so that it doesn't include everything here. For example, it doesn't include soil protein, but it does include some of the basic ones that basically, so wet aggregate stability, respiration are kind of, if you have to make it a choice on you know, an inexpensive option. So that's what we do. And then you can have the Cadillac package as well. That's a little bit more. And then you basically also have soluble salts, heavy metal screening, and then you have the bean rot bioassay. You can also get them a la carte, so if you just want one of those. But the vast majority of the samples that we analyze is basically the standard package. Okay, so quick summary of our approach, and I'll talk about some other approaches as well. So we focus on measuring the constraints and where the problems are, focused on processes and functions, all three realms of soils, nonlinear scoring functions, kind of a fuzzy approach for those of you who are the geostatisticians, really that's what they are, fuzzy scoring functions. We have these different tests. We include management recommendations, and we ended up developing a decision process. So if you're interested in some reference material, we have actually just a new manual that we just put online. This is our website here. If you Google Cornell Soil Health, you'll get there. This is the new training manual that we developed. It's about 130 pages. It's quite extensive, and it's a lot, basically what I presented here, but then in a lot more detail. Okay. We also have standard operating procedures if you really are interested in knowing exactly how we do that. You know, weigh 20 grams of soil and then do this and this. It's all. If you're interested in sort of maybe a background textbook on soil health, this one here, Building Soils for Better Crops, which is now in the third version, is basically a book about sustainable soil management. That I think is quite approachable. I mean, it's not highly technical, and so even for a farmer or a consultant, it's quite a nice book, and it's now about I think it's a little over 200 pages. Both of these you can download as PDF files for free, so they're available. You can just get them. You can, you know, take a figure or a table out of it and put it in the presentation or whatever you want to do. One of the good things about writing a book through kind of a non-commercial publisher is that they made it available very inexpensively. The book at the bulk rate was $10, and so people used it in workshops and all that. And then they made it available for free to download. So that's very nice. So it's gone far and wide, that book, for that reason. Okay, so let me talk a little bit about other soil tests, because we're not the only ones who are working in this area. So one that also gained some notoriety, and then there were some concerns about that, is the so-called Haney test. You may have heard of that. It basically focuses on the kind of carbon and nitrogen and to some extent phosphorus components. So it includes respiration. Typically they use the Solvita test, and then the water extractable organic C and N, and then developing that ratio. And they developed basically a soil health index, which is basically that, respiration over, and basically what comes out of these tests. They also make recommendations, fertilizer recommendations based on that. That's what really got them in trouble, unfortunately. I mean, I think it's a worthwhile test, but I think that they took it a little too far by basically developing recommendations from that. But it's also commercially offered by one or two labs. Ward Labs in Nebraska is one of them. So the other ones, so the so-called Solvita test, you may be familiar with that. It's basically a respiration test, and they sell it kind of as a package. So you buy the containers, and it has these paddles in it that absorb the CO2, and then they have a reader with that. So it's relatively easy for a lab to start working with that. And then they also developed a variation on that, which is the soil labile ammono nitrogen test, which is basically, instead of wetting it with water, you're wetting it with sodium hydroxide, and then you basically kind of collect the. Basically, you have ammonium evolution from that, which is basically the result of the whatever ammonia or mostly amino N that's in the soil. So it's sort of a labile N test. It's being offered commercially. It's not been evaluated very much. But it's, the Solvita Woods End Lab, they're good people. They're trying to do good stuff. And so that may be something of interest. The other ones that, for those of you who are more into biology, and I'm a soil physicist by training, so this is, don't ask me too many questions about this, but the ones that are gaining a lot of attention is the PLFA, phospholipid fatty acid assessment, and the EL-FAME, which is a fatty acid methyl ester. My understanding is that the EL-FAME is a more effective and less expensive way to measure. And then basically what you're after is the microbial community profile through a relatively inexpensive test. And I'll come back to that later. But that's not been as widely offered, but it's a little bit more still in the research area. And then also the beta glucosidase, which is more of an activity test, like respiration. So it's an enzyme activity test, and that's been promoted as well. It's also not really widely used in sort of the real world environment. Still a little bit in the research environment. So one of the things that we were really interested in, and the Soil Health Institute took a lead on that, is to come to a national consensus on a soil health test. So there's going to be a lot of soil health tests done in the next decade or something like that. It's a big deal. So let's at least come to a consensus on what constitutes a soil health test. Let's agree on the standard operating procedures. Let's agree on the methodologies and all that. And in fact, that's something else that I definitely want to relay to you as well, that we not only do this at the national level in the US, but that we do that at the international level. We have this opportunity now, because it's sort of new, to try to come to a consensus before everybody invests money in labs and they all start to do it differently. You use 20 grams, I use 30 grams, or I use this water stability test and you use another one. Sometimes, maybe they need to be cross-correlated. Sometimes you can't necessarily use the same test. You can't in a desert soil versus an Arctic soil. Maybe you can't use the same test, but try to make it as much compatible as possible. So we had this meeting in February in Ardmore, Oklahoma, where the Noble Foundation is. This cast of characters got together, and we're trying to hash that out, and we're still in the process. So one of the things that we did was basically say, well, which processes do we really want to have represented in a national soil health test? So we said, well, these are sort of the most important processes that we want in there, right? And then what are the best available basically indicators of that? So you can see with general biological activity, we're still kind of debating between two. Some people really like respiration, other people don't. I think respiration actually is quite good, and it's very simple. But some people say, no, we need to do the beta glucosidase. EL-FAME appears to be more popular than the PLFA. People think that it's more implementable on a commercial basis. Aggregate stability, active carbon, soil protein. So you see those. So a lot of that, mirrors our Cornell Soil Health test, but this is, it's going to be changing a little bit. And it's actually been interesting. So you can appreciate this as scientists. So you're having a room full of scientists, and you try to come to agreement on testing methodologies. You know how that works, right? And so we actually ended up having red cards, yellow cards, and green cards, and we voted. And so green card was like, yeah, this methodology is great. There's no concerns. And then yellow was like, well, yeah, it has potential, and red was, no, I don't like that one. And we ended up, basically, because we were going round and round and round and round, and at some point in time, you need to have a process to say, well, let's at least sort of take inventory of where everybody was.
Didn't they want to have 5 categories?
Yeah, that's right. Yeah, we should have had 5 categories. But you know how that goes. It's really difficult to get people to agree. And in the U.S. we have this land grant system, so every state has their own land grant university, and they have traditions of developing their own tests and all that. And we don't have as much of a tradition to say, oh, let's just discard this one because this one is better. No, people keep doing the same thing.
So the land grant universities get money from the government to do research that is, used and communicated by the public.
Right, right.
We don't have that here.
Yeah, it's a different system a little bit. Yeah, yeah. So just briefly, I wanted to, this is something that we started more recently pay attention to because we focus so much on that surface soil, and in the context of some of the global threats and climate change and extremes and all that, we really do come to realize that subsoil is also very important. And of course, why don't we measure much of the subsoil? Right, because it's a lot harder. Right, it's so much easier to sample from the surface. So, in a typical system, you have that surface layer, you have the subsoil, and then you typically have a transition layer, especially in a plowed system, where you basically you put typically what's at the surface, it's crop residue or whatever, or rotation crop, and then you put it here at the bottom of the plow layer. So I had a PhD student who did a little bit of work on that, and we had some plots that had been long-term no-till and long-term plowed. But in each case also, as a cross-treatment, the residue returned or the residue harvested. Okay, so this is more like a silage system, or maybe where you harvest the residue for a biofuel, and this is where you return the residue. So with the no-till, of course, it stays near the surface, and any transport into the soils primarily through roots and exudates and bioturbation and biopores and all that. While in a plowed system, of course, if you have any residue, then you basically put that at the bottom of the plow layer by plowing it, and it sort of gets mixed in after several years, right? So you get that kind of odd situation where you put this biomass right here at the bottom of the plow layer. And one of the interesting things that came out of this, and I'm just kind of summarizing, you see a lot of numbers in this table, but this is different depths, 0 to 6, 6 to 18, 18 to 30, blah, 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 all the way down to 60 centimeters. These are the different treatments, right? No-till with residue returned, no-till with residue harvested, plow-till returned and harvested. So what you see, and I just did some color coding, so don't even look at the numbers. Most of the times they're significant, but not always. And you see that the no-till returned has the best, basically, biological indicators, the best health, because that's the blue one, okay? And the plow-till, where you don't return any biomass, of course, is the worst. And that's in the surface layer and the second layer, okay? And then this is the transition layer, where basically in the plowed system you're putting that biomass at the bottom of the plow layer. And so here's a little bit mixed again, right? And so in some cases, basically here what you see is the benefits of returning the residue rather than harvesting the residue. And then you go deeper, and this is interesting, so let's go to the bottom. So at 45 to 60 centimeters, the no-till system gives you basically better biological conditions than the plowed system. Even though in the plowed system you're putting some of the organic matter at the bottom of the plow, you incorporate it into the soil. It's actually, the biological system works better by keeping the residue at the surface and allowing the organisms to take it down into the soil, which is really very interesting from my perspective. So what you do at the surface actually impacts the quality of the soil deeper down into the subsoil. Okay, so we don't really know that much about it, so we need to start doing that. So when we talk about soil health, especially to a farmer, I mean, you have to justify why they're spending money on a test, why they should be changing their management practices. So you have to also talk about how you monetize soil health. And so one, of course, is, well, your yields are better, right? Water conservation, better water uptake, biological synergies. Hopefully you can reduce your inputs. You have a more resilient system, maybe less irrigation water, less nitrogen fertilizer, maybe less pesticide use. And this one, I think, is one that I'm very interested in, is higher land value. Right? So you're investing in your land, and that should be represented in a higher value of your land. Similar to you invest in your home is worth more. And we are not good at valuing land, certainly not in the US. Okay? If you think of the value, actual value of land, how much it's worth, and how sophisticated we are about actually assessing the value of land, we're doing a terrible job. And so these soil health tests actually can help us with that. Also, of course, this whole ecosystem part of it, you can justify that. Maybe the provincial people here are interested in saying, look, we're improving the land. This is good for society because it's a national treasure. Okay. I mentioned the supply chain initiatives that we have in the US, where big food companies want to project sustainability image. Sometimes high-end restaurants who like to be able to say, oh, this food came from really good soil and been very well cared of. And the same way they can say, well, you know, this meat is, you know, from a pig that's been massaged every night, and you know, all that. You know, I mean, people pay for that, really. Okay, I'm going to finish up with a few minutes to talk a little bit about soil health and nitrogen, because I know some people in the room here might be interested in that, because that's also a way to capitalize on the value of increased soil health, because you have more organic matter nitrogen cycling, and you have reduced opportunities for denitrification by reducing compaction, of course, or reduced leaching by deeper rooting. So we developed this tool that you may have heard of AdaptN. It's now been commercialized 2-3 years ago. It's a cloud-based computational tool basically for nitrogen management, focused on maize production and soon also wheat. So we developed that at Cornell. We rolled it out in 2008, decided to license and commercialize it a few years ago to a startup company, Agronomic Technology Corporation. We're now linked to several of these industry data platforms, and we also are part of the some of the sustainability initiatives like Walmart, General Mills, and all that. So it was based on, some of this may look familiar to you, was based on a soil model that was developed by my colleagues at Cornell. We're still working with John Hudson, for those of you who know him. He's in Australia now. I know Miriam worked with Jeff Wagonette. And you know Mary Ellen, maybe actually Mary Ellen is retiring at the end of the month, FYI. And then we combined it with the Sinclair and Mucho crop model. So these are basically the inputs into the system. So it's a daily time step model that you kind of know what those models are. We use a mass balance approach to determine the optimum N rate, which has both a deterministic and a stochastic component into it. Deterministic in terms of what happens up till the date that you do the simulation, and then stochastic subsequently, with an economic component and risk factors. The weather inputs is a very important component, and then we have various soil and crop inputs that, you know, for those of you who do modeling, it probably looks fairly familiar to you. So we now have much better weather inputs, and you know, weather defines so much of the nitrogen dynamics. So having good, we're using the 4x4 kilometer product, and it is so important because especially growing season precipitation is highly variable. You know, within, as you know, you can have these intensive thunderstorms, and they're highly spatially variable. So this is what a recommendation would look like. So in this case, it's 60 pounds per acre, you know, English units, of course. And then we back that up with basically a lot of those simulation results. You know, how much nitrogen is now in the soil, how much is now in the crop, how much additional fertilizer is needed, how much rain did you get, what's the water status of the soil, so you can use it for irrigation purposes and all that. We basically have it now available at 3 different time scales, so you can either do it on sort of a field basis, or you can do a polygon-based variable rate, or you can do a gridded-based variable rate, so 20 by 20 meter. And it depends a little bit on which software we basically link in with. Okay. So here you can see a VRT recommendation, and it kind of gives you the little bar chart of how much to put where, and then you can export it, and you can tell the consultant or so this is how much anhydrous ammonia or urea or whatever you need. So this to give you a little bit of a sense. A lot of graphical outputs that helps you interpret the numbers. We're actually doing a really significant educational job by having a tool like that out there as a commercial tool. People are learning a lot about nitrogen dynamics. They're starting to understand, you know, when you lose the nitrogen and how much mineralization do you get. And, you know, this is a black box to most people. Okay. Has, of course, because it's in the cloud, you have all these communication capabilities. You can send these daily alerts and all that, and people can use it on their mobile devices, and you know, whichever way. I won't go into details, but we spent a lot of time basically proving the technology. You know, proving that that these recommendations are better than what you had, the static recommendations, okay? And so we do a lot of on-farm experiments. We've done well over 200 now in places like Iowa and Indiana, Ohio, Wisconsin, New York, Maryland. And we've been basically, if you have these kind of rate response trials, you can determine the economic optimum end rate. This is the adapt end rate, and it really tracks it quite well. We're very pleased with. We've tweaked the model well enough that it really does quite well. Okay, this is, those of you who've worked in nitrogen, RMSEs of about 30 kilograms per hectare is nice. Okay, and we were able to achieve that because we had a lot of good people over the years who worked towards these models and really were very rigorous about implementing these models. And so now we can use that. We can also demonstrate really win-win opportunities, which is really great. You can say, look, you can save money by using a tool like this, and you can reduce the environmental impacts fairly significantly simply by following the recommendations. Okay, we're not even talking about changing management practices, just following those recommendations. So that's so this has become part of those supply chain initiatives, the Nutrient Star initiative, and all. It's really trying to get people to start adopting better recommendation tools. In this case, a dynamic recommendation tool. Okay, and I think that's it. I guess we did pretty well on time. Thank you very much. I want to point out that it actually, I noticed, it says it here in Dutch and it says here bedankt also in Dutch. So Dutch is represented twice. Yeah, maybe it's Belgian, or here's a donkey also. If you like Afrikaans, it's also somewhere there. So, but Dutch is a special language.
Dankjewel, dank je, bedankt. Thanks, Harold. What I like about what you guys do is that you bring the science to the people, and I think it's very hard to do indeed the financial communication. Not just showing you can do this, but this is also why it's financially interesting for you. So yeah, thanks. Yeah, questions. If you have a question, please also state your name and the group where you're working. And I realized I forgot that. So my name is Catalina Stoof, and I work in the soil geography and landscape group of the university. Violet.
Yeah, I'm Violet Geis, and I'm in the coordination team of the Ice Quaker project. I'm working at the university as well. So we contacted you before, and we are really interested into the methods, the framework you developed. And what I was really astonished is how cheap you can offer the soil analysis. We tried to make some analysis, and they were offered us from here for more than €400 one soil sample. So that makes it impossible.
Send them to us.
That's what my idea is. No,
we'll
that is
for €400.
Yeah, no, but that is really interesting for us, or maybe for others as well. I don't know whether it's possible to send soil samples to the United States with all these custom things. I really, yeah. So the methods you apply, it's for you, for the laboratory, it's plus minus zero. You even earn some money from this, what you do.
Yeah, because we're at the university, we can't make a profit on it. So it's really, it's the true cost.
Okay.
More or less. Yeah, we do, by the way, we can import soil samples. We do have a permit for that. But, you know, I would really suggest that I mean, it doesn't make any sense to, you know, only on a short-term basis maybe to cross-calibrate labs or something like that. But, you know, I would really strongly encourage you to set that up here. It's really not that expensive. I mean, you know, we spend quite a bit of time streamlining the operation. You know, that's, you know, you start to do it. But, you know, after a while you say, oh, we can make this more efficient, we can do this more quickly. So that, you know, let's say $100 for a standard test, that's pretty realistic, and I don't see any reason why you couldn't do that here.
And one additional question is the respiration. Do you take soil samples then at a certain moment in the year, or in springtime, or doesn't it matter?
We try to encourage people to sample in the spring. That's the best time, or sometimes in the fall, which is also okay. But we try to move people away from summertime. You know, when we designed the test, I mean, you know, we all have these books on our shelves, you know, methods of soil analysis, and you have, I don't know how many, you know, hundreds of ways to analyze soil. So you know, we actually started out with about 40 different indicators, biological and physical, the chemical we
we didn't bother with, and then we sort of went through that, and so you have things like, for example, bulk density, right? You think, oh, bulk density, that's a great indicator. What you find is that it's not practical, in the field. I mean, we know how to take a bulk density sample, but a typical farmer or consultant doesn't. They aren't precise enough. And with bulk density, if you're off by 5%, that's a big deal. So it's not precise. Or you have other indicators where you find, okay, I sampled it in April, and now and I sampled in May and in June, and you see a lot of variability. So you need to have something that's consistent. You need to have something that's reproducible. And so that's how you sort of we ended up with the indicators that we have measured. Yeah.
Yeah, there was a question here. Yes.
Yeah, hello, my name is Benjamin Rosen. I'm starting here next month in molecular biology.
Oh, great.
Actually, I downloaded both of your publications and I've read them in preparation for coming here, and I had a whole lot of questions. I don't want to go through them all now, but the big question is, your analysis of the soil microbiology seems to me very superficial. When I do this, I try to quantify in micrograms per gram of each of the categories of microbes that you get in the soil for each of the trophic levels, and then try to come up with an advice about how you might introduce those microorganisms to the soil.
Mm-hmm.
And there's nothing like that in your work. Have you considered anything like that?
Well, especially with the biology, this is real trade-off in cost, and so we felt that we would stick with one activity measurement, which is respiration, and then sort of 3 inventory measurements, so proteins, the active carbon, and the total carbon. And but I agree with you. And I actually, in fact, we're starting a project where we're doing basically a total DNA sequence, which is now, the sequencing is now probably $20 to $25 for sampling. So that's definitely the next step. But for now, we had to go with something that was inexpensive, just to keep the cost down. We felt that $100, $9,500 was about as far as we wanted to go.
There's a firm here which does the DNA, and they're charging in thousands of euros to do one soil sample.
Oh, really?
So there's a big difference in prices, and I echo what you said before about prices. I can't see how you can possibly do it at that price. Just to do an ion-use light microscopy, and you can tell a lot from that. And even then, I can't make a go of it unless I charge a few €100 per sample, and it's only 2 hours of work. Plus, I've got to drive there and collect the samples and come back.
Right.
Your prices amaze me.
Yeah.
Well, you have to think about how valuable is the information, and what's somebody willing to pay for that information. And so you can look at it as an entry point. Say, most people just think in terms of the chemistry of the soil, the phosphorus, potassium, the pH. So now we're at least getting them to think about the biology and the physics of the system. And I think that because there's so many fantastic advances now being made in the biology realm, right? I mean, the physics, we've been doing kind of the same thing for a long time, but the methodologies in biology are advancing so quickly, and the prices are coming down so quickly. So I think that's going to be evolving. 2 years from now, 5 years from now, my colleague, like I said, Dan Buckley, he came to me. He said, I think I can do a partial DNA sequence for $20, $25. Let's give it a shot. I don't know how he does it,
but then his salary is covered by the university, and then it's just sample processing, because this is one thing I've been amazed about as well. I mean, when I came back and we talked about soil health in your soil health work, I was like, yeah, but for that price, I mean, it's very challenging to do that in the Netherlands. So because the salaries are they need to be accounted for as well. So
yeah, but I mean, in our case, the development, of course, was part of research project, and people like me who have university appointments. But currently the way the $9,500, that's the actual cost. So you pay a technician $12, $15 an hour, and you have I mean, if you organize it, like I said, the equipment really isn't very expensive. But I think it's important to look for ways to make it economical, because otherwise people are not willing to do it. So what do you prefer? Having maybe a test that's not quite as sophisticated, but people are willing to pay for it, or nothing? And so that's kind of where we are. And I see 5-10 years from now, we're going to have something much better, or at least we're getting started on it. Yeah. And the same with the EL FAME and some of those tests, which I don't really know much. You probably know what that is, but you know, my colleagues tell me, look, we can do that for relatively low cost.
Marcos and then Una and then Miriam.
Okay, I'm Marcos Angelini. I'm doing my PhD at Sociography and Landscape and District group. My question is about the spatial variability of these indicators. Have you tested this? How they behave in spatial? Or have you considered to create spatial information about these indicators?
Yeah, I mean, for those of you who know what I've been doing over the past 25 years, I've spent a lot of my time looking at spatial variability. So in this case, we're sort of space neutral. You know, we're basically saying you are assessing a unit of land. So that may be a field, or maybe part of a field, or maybe a problem area in a field. So, and then we say, well, within that area, you just collect a representative sample. And so in our manual, we have some guidelines on how you do that. Basically, you go to 5 locations and you do some subsamples and all that. Yeah, I mean, spatial variability, you know, again, a farmer is not going to be willing to do gridded sampling and spend, you know, $5,000 on analyzing it. So they're going to be saying, okay, maybe willing to get, you know, 1 sample per field, maybe 2 samples per field if there's a problem spot or something like that. And then you just average it out. Now, fortunately, most of these indicators are quite well behaved, statistically speaking, so they have kind of normal distributions. They're not highly skewed or something like that. So you don't have a big problem with you know, getting basically biased answers, or, you know, something that. So that works out very well. But we basically said the test is for the unit, for whatever you define that unit to be. Now there is some interest in starting to map it. Actually, David Rossiter, probably some of you know him. He also walks around here quite a bit, but he also is a colleague of ours at Cornell. He actually wants to, because we now have over 8,000 samples analyzed, so he wants to start doing some mapping. Now, one of the interesting things as an aside that we found is, we looked at, for example, samples that we'd collected in the northeastern U.S. and in the midwestern U.S., right? So places like Iowa. And we expected that the Iowa soils would be much better. These are mala soils, you know, great soil. I mean, Iowa, some of the best soils in the world. And then we looked at all these indicators, and they weren't all that great. They weren't any better than the northeastern soils. Why do you think that is?
Maybe that's because you only focus on the topsoil.
That's right.
Yeah.
Because where those Iowa soils, those mala soils are good, is in the subsoil. That's where they are much better than the forest soils. In the surface, not. So you look at if you characterize an Iowa soil based on the 0 to 15 centimeters, they're not much better than most other places. You have to go deeper into the soil to really appreciate these mala soils.
If I can add to the spatial variability thing, from this bioenergy project, we have in a field in which the recommendations say take 2 samples, at most 2, we have 120 collected over, well, this year was the 5th year, I think. So one of the ideas is to use that data set and look at the small scale spatial variability. If anyone knows a student who is interested, then that would be great. But yeah, that is one of the things. Una.
Yeah, Unema from Soil Quality. Yeah. I was wondering how your farmers appreciate the soil health concept. So you provide them one number, and farmers like to have easy thing. So 88 or 16.
Right.
But on the other hand, they're also interested in high yields. They want to have 15 tons wheat or 20 tons of maize.
Right.
So I was wondering whether you have a kind of correlations, whether you related your soil health indicator to crop yields, or whether you have related the soil health concept to, for example, the vulnerability to soil erosion,
right.
nitrate leaching, overland flow, and that kind of thing. So that's really, that the high soil health
Yeah,
value
yeah.
has really a value to farmers or to the environment.
No, I mean that's an excellent point, Una. So, one point I wanted to make also is soil quality versus soil health. One thing that we found that farmers respond much better to sort of the concept of health because everybody understands health from their personal perspective. But yeah, no, I mean there is kind of it's really what you want to get at. You want to be able to say, you know, if your health score goes up by this much, then your yields will go up like that. We have some data to show that. We've done some work in Kenya, we've done some work in Iowa, and some work in New York that shows that. But it's not a really tight line as you might expect. And the other thing that you can then do is you can say, well, which of these indicators are most predictive? And actually, the active carbon is a very good test. So if you only were to measure one thing, measure active carbon, it's relatively inexpensive. But it is sort of the holy grail of soil health. It has to mean something in terms of either reduced inputs or higher returns and revenues. And yeah, so we're kind of working on it, but it's not easy. It's very difficult to collect that kind of information. You almost need to have a controlled trial where you irrigate and you don't have any other yield constraining factors where you can then really make that kind of a comparison. But I agree, because ultimately that's how you need to justify it, right?
So, but then I was wondering how you discussed that in this group. I mean, you come up with how many indicators are in the soil health?
So there's 16, yeah, and
But
that
then
includes
you
micronutrients.
would like to have also that it is analytically sound, that you understand what it does, what you measure.
Right. Yeah, so to some extent, you rely on what we know from past research. We know that aggregates are important and that stable aggregates in general reduce runoff and erosion and are better for aeration, blah, blah, blah. And then you can say that for all these other active carbon and all that. So that's kind of what you base it on. You say, well, this is better. I mean, it's again a little bit like human health. If your blood pressure is lower, it's better. If your cholesterol is lower, it's better. It doesn't mean that you can't drop dead tomorrow. But and so that's the way we convey it. But you're right. It's a little fuzzy. But that's kind of how holistic management is. We've also kind of oversold the simplicity of the traditional soil testing. We've said, well, if your P level is below 20, whatever extractant you use, then you have a problem. And if it's above 20, it's fine. That's not really true either. But we've kind of given people that message, right? I mean, let's be honest. And so this is in a way a little bit more complicated. We can't say aggregate stability, if it's below 45, then you have problems, and above 40. But sort of in general, more is better here, more is better there, and all together.
Okay.
But if nothing else, it makes people pay attention, right, to something more than just nutrients and pH. Yeah.
All right, Miriam had a question?
My name is Miriam Burman. I work in the soil quality group here in Wageningen and also in SIAT in Colombia. And part of my question was already answered, because I was going to ask, are you doing something with all these data that you are collecting? So to look at correlations and. But it was already answered, but then I had another question. So you said that these active carbon index, that for you was the best indicator if you have to choose one. So what does it correlate with exactly? And my other question was about NIRS or NIRS. Do you use infrared spectroscopy for this or not, and why not?
Yeah, so having over 8,000 samples becomes a nice, rich data set. So we do a lot of multivariate analysis. So we've done a lot of PCAs and best subset regressions and things like that. So that's where active carbon kind of comes out. As this is really a very useful indicator.
That means that it's correlated with some of the other indicators that you are measuring, or.
Yeah, there are correlations, right? And so that's the same when you get with the reflectance spectroscopy that you mentioned. So we've done a lot of NIRS work. And so you have these, you know, because what you measure with NIRS is those bonds, right? Those particular bonds that you're after. So you get a lot of those correlations. And what you find with soil health is, yes, you can measure, you can do good assessment of, say, clay content. You can do good assessment of organic carbon with NIRS. But then with some of the other ones, it doesn't work quite as well. And what we found is that you can combine NIRS with sort of the standard soil test, and I think it was aggregate stability. And then if you have all that information, then you can kind of fill in the other ones using reflectance spectroscopy approaches. So there are, yeah, we've actually done some work on that. I'm not completely satisfied, and you know, NIRS is great, but if you have an inexpensive way, say active carbon, you maybe don't want to use NIRS because it's really cheap to measure it the real way, you know, so you always have that balance. But yeah, we're learning a lot from the multivariate analysis, you know, and we're actually kind of in the middle of that, so we'll be putting some stuff out in the literature pretty soon. Also allowed us to fine-tune our scoring functions, you know. And that is one of the challenges. You need to really invest a little bit in defining those distributions and, you know, understanding, I mean, what is a distribution of aggregate stability in this country or in Germany or something like that. So actually that brings up another point. I wanted to make that. So one is that, you know, we really like to see, this is my year as the president of the Soil Science Society of America, so I have the ability, you know, to say something about that. And one is we really need to be better about standards in soil science, and we really need to work at the global level together on that, so that we measure the same things. The other thing is we need to have an interpretation framework that is not just by country, but that is also a global interpretation framework. So you may say for a Dutch soil, aggregate stability of or Dutch sandy soil aggregate stability of 30% is great. But we need to be able to say at the global level, so that we can say, you know, soils in Mali versus soils in Holland or soils in Iowa, that we can actually make some relative assessments. So, but you can't, so you need, in a way, you need to have local scoring functions, but we need to have global scoring functions so that we can really start to compare our soils, right? And of course, we're terrible at that in soils. And how many soil classification systems do we still have? Right? 5 or 6 or something like that. You have your own one here, right? Yeah.
Oh yes, we do.
You know, this is the 21st century, and we're still, you know, and we need to come together on that. It's something we have to solve.
This would be a nice concluding remark, but there was one last question in the back.
Okay, yes.
Thank you very much. I'm Jack Gopi, working at the history. We are working here together with Realite. She just mentioned for the East Quad project. So while I was targeted to develop the so-called soil quality arc, and for that we need to select the soil quality indicators. One of the consideration for the selection is to identify, to assess the measures for these indicators, either in the field or the laboratory, quickly and economically and so on. So my question is, your soil property, soil protein is determined in the laboratory or it can be measured in the field?
No, it's done in the lab. The only thing that we measure in the field is the penetration resistance with a penetrometer. Everything else is done in the lab. I mean, I think that you could actually, with smartphones, you could do something. You could reasonably estimate organic matter contents, for example, with smartphone. And I think that's very worthwhile. We have a project in India where we're trying to look at a kind of a lab in a box, where you basically a relatively small lab. You may be familiar with the one that Pedro Sanchez has been promoting, Ray Weil. So we're trying to look at it. That one's maybe a little too complicated, but it's nice if you can go out in the field and make some observations that are maybe not all that sophisticated, but if you're there with the farmer and the consultant, and they see what the numbers are, you can say, you take a sample from here, from the middle of the field, and then you take a sample from a fence row or something like that, and then you say, look, you know, this is how. Look at the structure. Look at the organic matter content, and you do a few measurements. I think that's really useful because part of it is an educational effort. Yeah. So, yeah, the more we can do in the field, but you know, our philosophy initially was that field measurements are qualitative. You can't really do good quantitative measurements in the field. You know, if you do, you know, you're messing around in the field and, you know, trying to, you know, extractions, reagents. There's no way you can do that. You know, you need to have it in a controlled environment. But you know, you may be familiar with some of the soil health kits that's been out there, and that's really nice to, you know, take out in the field, and you can learn a lot from that. But at some point in time, you need to have a more quantitative framework. Yep.
All right, thanks for all your questions. Thanks, Harold, for coming here.
Oh, my pleasure.
As you saw, Erik van Elten from Ontario, he taped the presentation. So if any of you is interested in the video, you can leave your name and your email address with me. Then we'll send you the video. Or if you know people who may be interested, please leave your contact information. Thank you.